Now, example number 2, what is, if I say f of x equals x squared, that's my parent function. Then if I say g of x is equal to x squared minus 5, and h of x is equal to x squared, or x minus 4 squared. Okay. So let's graph those and see what the difference is. Okay. So what I'm going to do is I'm going to come back to my graphing calculator. Can you guys see that? Okay.
That minus s?
No.
No, I can't see
That
that.
minus s?
Minus 50. Wait, where are you where?
Oh, g of x.
Oh, never mind. My bad.
No, it's, why would it be minus s? It's minus 5.
I thought you were talking about the curve.
Make that a little bigger.
Nice.
There you go.
Okay, now you can see a little better. So let's go in here. Let's clear this. Let's make this x squared. For g of x, we had x squared minus 5, so I'm going to say x squared minus 5. And then, whoops, I got to delete that other stuff, I guess. And then for our third function, what we're going to do is, in parentheses, I'm going to put x minus 4 squared. Okay? Now, let's look at the table of values first. What do you notice between y1 and y2? With regard, there's a pattern there.
Minus 5.
It's 5 units down.
Yeah, it's 5. You're subtracting 5 units from whatever the y value is. So y1 is our parent function. The origin is the vertex, which is 0, 0, right? But where is the vertex of y2?
5 units down.
Yeah, it's 5 units down. 0, comma, negative 5. Now, where is y3?
4, 0.
Yeah, so there's something different going on there. So let's just look at this. Let's look at the graph and see what we end up with. So there's our parent function, there's the second function, and there's the third function. What can you conclude based on this graph? What does this do to the function?
Vertical shift down 5.
Yeah, it does a vertical shift. And this should be kind of a refresher from last year. Now, is that in parentheses at all?
No.
No. So what we're saying is we had an x squared value, whatever number that is, subtract 5 from it. What that does is it vertically shifts the graph down 5 units. So a negative value shifts down. What do you think a positive value does when we add shifts up? Now, I've got minus 4 here. Let's look at that graph again and tell me what you think it's doing with respect to the blue function or the parent function.
Horizontal shift.
Yeah, this one is, it's not a shift, though technically we should say translation, right? So, but we could say a horizontal shift, but it's in the opposite direction. It's 4 units to the right, right? So this one is interesting. This is kind of a horizontal, we'll say shift. That's not, I spelled it wrong. Horizontal shift. And so now if it's negative, we're going to go to the right. If it's positive, we're going to go that many units to the left. So this one went 5 units down, and this one went 4 units to the right. And that's all that does. Yes, question?
Why is it so that the negative one moves it further positive and the positive one moves it more negative?
Well, I'm going to show you in a second. So the question was, is why is it on this last one, it's the opposite sign of the direction that you move? Well, I can answer that, but it's really, it just boils down to the math. But that never changes. Okay, what we're doing is we're going to square this number, and when you square this number, it becomes positive.
But how would the positive move it negative?
Oh, well, it has to do with the... I can answer the question, but my answer to the question will be so complicated. It's not complicated, it'd be long-winded, and it might take us off track.
And you don't need it.
So I will when we get to that point, I will explain in full detail. But basically, there's a relationship. This is one way that we can represent quadratics. Well, I'll give you a short version of it. If I say j to the x is ax squared plus bx plus c, this a term is basically going to be the stretching and shrinking. This is still going to be the vertical shift.
So what's the
B is a little bit different. B is actually going to be the vertex slides or glides over negative x squared, which is kind of a weird and confusing thing. And so basically, mathematically, what happens if I were to write this out, if I were to expand that, I would get x squared minus 8x plus 16. And so what we do is we get a vertical shift up of 16, but then we get rotated down.
Do I write that?
And no, you don't have to write this down. And what this does is it just moves it 4 units to the right. You want me to prove it to you? I'll show you.
Oh, I get
Wait,
it.
do I have to
Yeah.
do the J
So
of
it's like you square root the
you don't have
16 kind of.
Well, kind of.
Compared to
Well, all right. You know what? This is a good practice. Let's just do it. It'll be good. Some people watching the video will think it's kind of cool. So, let's do that. So what I'm going to do is I'm going to clear this out just so you guys know. If I expand that, I get x squared minus 8x plus 16. And so now if I graph that, you'll see that the black graph, whoops, I must not have entered it in right. Oh, I see what I did. I didn't do the right sign, a negative sign. All right, there we go.
It should line up on top.
Yeah, it'll be right on top of each other. See how that is?
Yeah.
Now here's why. Watch this. What I'm doing, if I say negative x squared. Watch this. This is kind of cool. All right. Now I'm going to take a fourth function. I'm going to come down here, and I'm going to say x squared, right? But now what I'm going to do is I'm going to minus 1, whoops, I minus 1x and graph it. Now what that does is that shifts that about that red graph, or the purple graph. See how that green graph is shifting around?
Yeah.
Okay, now watch this. If I change that to 2, minus 2, what it's going to do is watch how that new green graph kind of sticks to the purple graph. The vertex kind of sticks to that purple graph. See how that does that?
Moves along on the purple.
It moves, so this is going to move along this path as that b value changes. Okay?
If you were adding a positive x, would it go the other way?
Yes. Yep, that's a great question. So now I'm just to kind of speed things up. If I put a negative 4x, same thing. The vertex is just going to rotate around that upside down parabola. Does that make sense?
Yeah.
So now let's go in here. And you're right, you kind of take the square root is where it comes from. But if I put this 8 in here and I graph it, notice that the green graph is directly below the black graph. Okay, so now as I come in here, if I start to shift this vertically, and I'll do it in increments, if I do +2, that green graph is now just going to shift up 2 units from where it is. And then if I change that and I go to like +10, so this is being shifted up 10 units. So it was like way down here on that purple graph. And so when we're done with the whole thing, mathematically what happens is when I come down here and I put it at 16, get this. Does that make sense? So it's a lot easier just to know that this -4, when it's inside the parentheses, will shift it 4 units to the right. And if it's +4, it shifts it 4 units to the left.
Or if it's a +16, but outside of the parentheses.
Yeah, it would shift it up, yeah.
does this.
But this always applies. So basically what I'm showing to you guys is this, that if you have f of x, right, and you have a times x minus h squared plus k, that h comma k is always going to be the location of the vertex. Okay? And that's just by the manipulation of how the numbers work out. All right? Where h is also the line of symmetry. So x equals h, whatever the h value is. And then k would be what we call the vertical shift. Sort of. Well, sort of. Because remember, when we did this problem, when we manipulated this equation, as you expand it, you'll get this kind of vertical shift. But when you write it in this form, you can graph it with a vertical shift, but they're two different vertical shifts. Does that make sense?
Yeah.
Okay. And then A, of course, that does the shrinking and the stretching. Okay? And it also does the flipping. If A is less than 0, then it flips it upside down. All right. So that's what we were leading up to in example number 2. Are there any questions?